write the number of terms in the expansion of 2 plus root 3 x whole power 10 plus 2 minus root 3 x whole power 10. We know that the binomial expansion x plus a whole power n is equal to nc naught x to the power n plus nc1 x power n minus 1 into a to the power 1 plus nc2 x to the power n minus 2 into a to the power 2 and so on up to ncn a to the power n. So by using this binomial theorem, we can write 2 plus root 3x whole to the power 10. 2 plus root 3x whole power 10, we can write it as 10c naught 2 to the power 10 plus 10c1 2 to the power of 10 minus 1, that is 9 into root 3x whole to the power 1 plus 10c2 2 to the power of 10 minus 2, that is 8 into root 3x whole to the power 2 and so on. We can write 10c10 2 to the power of 0 and we can write root 3x whole to the power of 10. And similarly, we can write 2 minus root 3x whole power 10. So which comes 10c naught 2 power 10 and here minus 10c1 2 to the power of 9 into root 3x whole power 1. For odd powers we will get negative. So plus again 10c2 2 to the power of 8 into root 3x whole to the power of 2 and so on plus 10c10 2 to the power of 0 into root 3x whole to the power 10. Now adding these two expressions, so we'll have 2 plus root 3x whole power 10 plus 2 minus root 3x whole power 10 is equal to, so we can cancel the terms which are positive and negative. So the terms gets cancelled here and so we'll be having only the odd terms, even terms. So 10c naught plus 10c naught 2 power 10, that is 2 times 10c naught 2 to the power 10 plus 10c2 2 power 8 root 3x whole power 2 and again 10c2 2 power 8 root 3x whole power 2, so that is 2 times 10c2 2 power 8 into root 3x whole power 2 and so on 2 times 10c10 root 3x whole power 10. So you can take 2 common. So we can take 2 common and we can write 10c naught 2 power 10 plus 10c2 2 power 8 into root 3x whole power 2 and so on 10c10 root 3x whole power 10. And clearly we can find the number of terms are here 2, 4, 6, 8, 10, means 2 to 10, that's a 5 terms are there here and including 0 it is 6. So total number of terms in the expansion is 6 terms, 6 we can write, or we can just simply remember if n is even, then the expansion x plus a whole power n plus x minus a whole power n, this expansion will have n by 2 plus 1 terms. So here n is equal to 10, so 10 by 2 plus 1, that is 5 plus 1, 6 terms are there for this problem. You can just simply remember this concept. Okay, thank you. Write the sum of the coefficients in the expansion of 1 minus 3x plus x square whole to the power 11, 111. We know that sum of the coefficients in the expansion is obtained by substituting x is equal to 1. Means by substituting the value, by putting x is equal to 1, we will be getting the coefficients. That coefficient, the sum can be considered by substituting x is equal to 1. So here sum of the coefficients in 1 minus 3x plus x square power 111 can be considered to be 1 minus 3 into 1 plus 1 square whole to the power 111, that is 1 minus 3 plus 1 whole power 111, that is 1 plus 1 2, 2 minus 3 is negative 1 to the power of 111, so which is equal to minus 1. So sum of the coefficients in the expansion of 1 minus 3x plus x square whole power 111 is minus 1. Okay. Write the number of terms in the expansion of 1 minus 3x plus 3x square minus x power 3 whole to the power 8. Let us simplify this. We can write this as 1 power 3 minus 3 into x into 1 square, 3x we can write 3 into x into 1 square, plus again 3 into x square into 1 minus x to the power of 3 whole to the power of 8. That is, it is in the form of a cube minus 3ab square plus 3a square b minus b cube, which is equal to a minus b whole cube. So we can write here, which is equal to 1 minus x whole to the power 3 and again whole to the power 8. That is 1 minus x whole to the power 8 3s are 24, since a power m whole power n is a power m into n. And we know that in the expansion of x plus a or x minus a whole power n, number of terms is equal to n plus 1. So here we can say, therefore the number of terms in the expansion of one minus x whole power 24 is 24 plus 1, that is 25. Okay. Write the middle term in the expansion of 2x square upon 3 plus 3 upon 2x square whole to the power 10. Since we know that in the expansion of x plus a whole power n, if n is even, then the middle term is n by 2 plus 1th term. So here n is equal to 10, therefore n by 2 plus 1, which is equal to 10 by 2 plus 1, that is 5 plus 1. So we can say 6th term is the middle term. So let us use the general term formula. TR plus 1 is equal to NCR x to the power of n minus r into a to the power of r for the expansion of x plus a whole power n. Since 6th term is a middle term, so we can write T6 is equal to T5 plus 1. So we can consider r is equal to 5 and here n is equal to 10. So we can consider 10C5 x to the power, that is 2x square by 3 whole to the power of 10 minus 5, that is 5 into 3 upon 2x square whole to the power 5. Upon simplifying, so this is 10C5, that is a 10 factorial divided by 5 factorial into 5 factorial, since we know that NCR is equal to n factorial by r factorial into n minus r factorial. So into here it's a 2 power 5 into x to the power of 10 divided by 3 power 5 into 3 power 5 upon 2 power 5 into x to the power of 10. So we can cancel the terms 2 power 5 and 3 power 5 here and x power 10. So we had finally 10 factorial by 5 factorial into 5 factorial. Let us simplify this. 10 into 9 into 8 into 7 into 6 into 5 factorial divided with again 5 into 4 into 3 into 2 into 1 into 5 factorial. So we can cancel here 5 factorial, 5 factorial, and on simplifying 5 2s are 10 and 3 4s are 12 or 3 3s are, we can add 4 2 times. So we have left with 3 into 2 into 7 into 6. 3 2s are 6, 6 6s are 36, 36 7s are, we can say 252. So 252 is the middle term. Which term is independent of x in the expansion of x minus 1 upon 3x square whole to the power 9. Let us consider the general term. We have TR plus 1 is equal to NCR x to the power of n minus r into a to the power of r in the expansion of x plus a whole to the power n. So let us write here TR plus 1 is equal to, here n is equal to 9 CR x to the power of 9 minus r into minus 1 by 3x square whole to the power of r. Simplifying 9CR x to the power of 9 minus r into minus 1 whole to the power of r upon 3 power r into x to the power of 2r. So 9CR minus 1 whole to the power of r upon 3 to the power r x to the power of 9 minus r minus 2r by using a power m by a power n is a to the power of m minus n. So we can write 9CR minus 1 whole power r upon 3 power r into x to the power of 9 minus 3r. This is the general term in the expansion. To get term independent of x, so we consider the power of x to be 0. So consider the power of x is 9 minus 3r. So let us consider 9 minus 3r is equal to 0. That is 3r is equal to 9. So we can take r is equal to 9 by 3, that is 3. So if r is equal to 3, then tr plus 1 is equal to t 3 plus 1, that is t4. Hence we can say that fourth term is independent of x. Independent of x in the given expansion. Okay. If a and b denote respectively the coefficients of x power m and x power n in the expansion of 1 plus x whole power m plus n, then we write the relation between a and b. We know that in the expansion of in the expansion of 1 plus x whole power n, coefficient of x power n is a coefficient of x power r. Let me write coefficient of x power r is NCR. Since 1 plus x whole power n can be given as summation r is equal to 0 to n, we can write NCR x to the power r. So the coefficient of x is NCR. And here in this problem, given a denotes coefficient of x power m, coefficient of x power m in the expansion of one plus x whole power m plus n can be given as m plus n c m, and which is denoted by a, and coefficient of x power n in the expansion of 1 plus x whole power m plus n is m plus n c n, which is equal to b. Therefore a is equal to m plus n cm and b is equal to m plus n cn. Since we know that NCA is equal to NCB, then either A is equal to B, or we can say the sum A plus B is equal to N. So here also we can see that the sum of M and N is the number of terms M plus N. So therefore we can say that M plus N Cm is equal to M plus N Cn, that is A is equal to B. So we can go ahead with answer A is equal to B is the relation between A and B. If A and B are coefficients of x power n in the expansion of 1 plus x whole power 2n and 1 plus x whole power 2n minus 1 respectively, then write the relation between A and B. Since we know that in the expansion of in the expansion of 1 plus x whole power n, coefficient of x power r is given by NCR. Since we know that 1 plus x whole power n is equal to summation r is equal to 0 to n, we can write NCR into x to the power r. So therefore by using this concept we can write, since a is the coefficient of x power n, so coefficient of x power n in the expansion of 1 plus x whole to the power 2n can be taken as 2n c n, and which is given by a. And similarly, b is the coefficient of x power n in expansion of 1 plus x whole power 2n minus 1. So that is coefficient of x power n in 1 plus x whole to the power 2n minus 1 is equal to, we can write 2n minus 1 cn, which is given by b. So therefore we can consider, let us consider the ratio a is to b. A is to b is equal to 2n cn is to 2n minus 1 cn, that is a by b is equal to, so we can write 2n cn upon 2n minus 1 cn. By using the formula NCR is equal to n factorial by n minus r factorial into r factorial, or we can also write n factorial is equal to n into n minus 1 factorial. Let us use this concept. So we can write a by b, which is equal to 2n factorial by 2n factorial upon 2n minus n factorial into n factorial, the whole divided by, and again we can write 2n minus 1 factorial upon 2n minus 1 minus n factorial into n factorial. Let us simplify this. This is a division, or you can simply write by. So a upon b is equal to 2n factorial, we can write it as 2n into 2n minus 1 factorial upon 2n minus n, that is n factorial into n factorial, the whole divided by 2n minus 1 factorial upon 2n minus n, that is n minus 1 factorial into n factorial. So we can cancel here 2n minus 1 factorial, 2n minus 1 factorial we can cancel, and here n factorial, let us write n factorial as n into n minus 1 factorial, so that we can cancel this n minus 1 factorial, and also n factorial gets cancelled. So finally we have a upon b is equal to, so here n and n gets cancelled, so 2, only 2, so 2 upon 1, or we can write a is equal to 2 times b. Therefore the relation between a and b is a is equal to 2b. Write the middle term in the expansion of x plus 1 upon x whole power 10. Since we know that in the expansion of x plus a whole power n, if n is even, its middle term is n by 2 plus 1th term. So let us use this concept here. So in the expansion of x plus 1 upon x whole power 10, so middle term can be considered, since n is equal to 10 here, so 10 by 2 plus 1, that is 5 plus 1, that is 6th term. So let us consider it's a general term. T r plus 1 is equal to NCR x to the power of n minus r into a to the power of r for the expansion of x plus a whole power n. So in comparing, we can write n is equal to 10, so that is 10c, and we want a 6th term. So 6th term is t 5 plus 1 we can write, so r is equal to 5, and x is nothing but x to the power of 10 minus 5, and a is 1 upon x, so 1 upon x whole to the power of 5. So we can write this is 10c 5 into x to the power of 5 into 1 upon x to the power of 5. So we can cancel this both and we can give the answer 10C5, or on simplifying you can give by using the formula NCR is equal to n factorial by r factorial into n minus r factorial. So we can write 10 factorial upon 10 minus 5 factorial, that is 5 factorial into 5 factorial, that is 10 into 9 into 8 into 7 into 6 into 5 factorial upon this 5 factorial we can write 5 into 4 into 3 into 2 into 1 into 5 factorial. So we can cancel this 5 factorial and also we can cancel certain terms. 5 into 2 10 and 3 times and 4 2 times 8. So we have 3 into 2 6, 6 sevens are 42, 42 6 are. So or else we can say 6 into 7, we can say 252 is the product. So 252 is the answer. Okay, or we can give the answer 10C5. If A and B denote the sum of the coefficients in the expansion of 1 minus 3x plus 10x square whole power n, and in the expansion of 1 plus x square whole power n respectively, then write the relation between A and B. And we know that to find the sum of the coefficients in any expansion, we can substitute the variable over here, x is equal to 1. Put x is equal to 1, you will get the sum of the coefficients in the expansion. So we will get here 1 minus 3 times 1 plus 10 times 1 square whole to the power n, which is equal to 1 minus 3 plus 10 whole power n, that is 10 minus 3 7 plus 1 8 power n. Say this is A given, and for 1 plus x square whole power n, so let us consider x is equal to 1, so we can add 1 plus 1 square whole power n, which is equal to 1 plus 1 whole power n, that is 2 to the power n. Say this is B. So we have A is equal to 8 power n and B is equal to 2 power n. So 8 power n we can also write it as 2 power 3 whole power n, and by using the properties a power m whole power n is equal to a power n whole power m, both are same, so we can add 2 power n whole to the power 3, and since 2 power n is nothing but b, so this is b to the power 3. So therefore the relation between a and b is a is equal to b to the power 3. Okay. Write the coefficient of the middle term in the expansion of 1 plus x whole to the power 2n. Clearly we can say that this 2n, it's an even number. It's a multiple of 2, it's an even number, and we know that in the expansion of x plus a whole to the power of n, if n is even, then its middle term is n by 2 plus 1th term. N by 2 plus 1th term. So here in the expansion of 1 plus x whole power 2n, so middle term we can take it as middle term is equal to 2n upon 2 plus 1, that is n plus 1th term. So by using general term we can add Tn plus 1 is equal to, since we know that for the expansion 1 plus x plus a whole power n, Tr plus 1 is equal to NCR x to the power n minus r into a to the power r. So here in the expansion of 1 plus x whole power 2n we can write 2nc n 1 power 2n minus n, that is 1 power n into a to the power n, that is x to the power n, that is 2ncn x to the power n. So we require only the coefficient, therefore its coefficient is equal to 2n cn. That's the answer. Okay. Write the number of terms in the expansion of 2x plus y power 3 whole power 4 and again whole to the power 7. On simplifying this expression, we can also write it as 2x plus y power 3 whole to the power 4 into 7, that is 2x plus y power 3 whole to the power 28. Since we know a power m whole power n is equal to a power m into n, and also now in the expansion of x plus a whole power n, the number of terms is equal to n plus 1. So here in the expansion of two x plus y power 3 whole power 28, the number of terms is equal to 28 plus 1, that is 29. So 29 terms will be there in the expansion of 2x plus y cube whole power 4 and whole power 7. Okay. Find the sum of the coefficients of two middle terms in the binomial expansion of 1 plus x whole to the power 2n minus 1. So clearly 2n minus 1 is, it's an odd number, and we know that in the expansion of x plus a whole to the power n, if n is odd, then there will be two middle terms. Then the middle terms are given by n plus 1 by 2 term and n plus 3 by 2 the term. So these are the two terms are produced. So here in the expansion, so in 1 plus x whole to the power 2n plus 1, middle terms are two n minus 1 plus 1 by 2 term and 2n minus 1 plus 3 by 2 term, that is 2n minus 1 plus 1, that is 2n upon 2, that is nth term, and 3 minus 1 to 2 times of, that is n plus 1 term. So these are the two terms. So we can write, and coefficient of coefficients, let us write nth term Tn is equal to Tn minus 1 plus 1. So we can use n minus 1 as r, and so we can write it's nothing but 2n minus 1 Cn minus 1 into x to the power of n minus 1, and T n plus 1 is equal to, we can take r is equal to n, so we can write 2n minus 1 Cn x to the power n. So their sum of their coefficients, sum of the coefficients of middle terms is equal to 2n minus 1 Cn minus 1 plus 2n minus 1 Cn, and we had a property NCR plus NCR minus 1 is equal to n plus 1 CR from combinations. This is one property we have. So by using this property, here n is equal to 2n minus 1 and r is equal to n, let us consider. So this can also be written 2n minus 1 Cn plus 2n minus 1 Cn minus 1. So here n is 2n minus 1. So we can give it as 2n minus 1 plus 1 CR. R is nothing but n. So that is, so you can get 2n minus 1 plus 1 is 2n Cn. This is n. So 2n Cn is the answer. Find the ratio of the coefficients of x power p and x power q in the expansion of 1 plus x whole power p plus q. So we know that in the expansion of in the expansion of 1 plus x whole to the power n, coefficient of x power r is NCR. Since we know that 1 plus x whole to the power n is equal to summation over r is equal to 0 to n. R is equal to 0 to n, we can write here NCR x to the power r. So the coefficient will be considered NCR for x power r. Similarly, in this expansion, so given the expansion of 1 plus x whole to the power of p plus q, so therefore coefficient of x power p will be considered p plus q c p, and coefficient of x power q in the expansion we can write p plus q c q, and we know that by the properties NC r is equal to NCS, then either r is equal to s or the sum of r plus s must be equal to the n. Clearly we can say here p plus q, it's here r p and here q, adding these two you are getting the number p plus q. It's a total n power, that is power of the binomial. So therefore we can consider that, which implies that p must be equal to q. So according to the question, the ratio of the coefficients will be considered, it's p plus q c, so which implies p plus q cp is equal to p plus q cq, Therefore, the ratio will be taken as 1:1. Write last two digits of the number 3 power 400. So 3 to the power 400 is very huge big number, and we need to find the last two digits. Let us use by binomial theorem concept. 3 power 400, we can write 3 power 4 whole power 100. So 3 power 4 is 81, 81 to the power 100. So 81 to the power 100, we can write it as 1 plus 80 whole power 100. So which is in the form of 1 plus x whole power n, that is summation over r is equal to 0 to n NCR x to the power r. So we can write 1 plus 80 whole power 100 is equal to summation of r is equal to 0 to 100 NCR, that is 100 CR x to the power r, which is equal to, let us take r is equal to 0 first, 100 C0 x to the power 0 plus 100 C1 x to the power of 1 plus 100 C2 x to the power 2 and so on up to 100 C100 x to the power 100. So here x is equal to 80. So let us write 100 C0 values, since we know NC0 NCN is equal to 1 and NC1 is equal to NCN minus 1 is equal to n. So 100 C0 is 1 times. So 1 times of x power 0, that is 80 power 0 is 1 plus 100 C1, that is 100 times x to the power of 1, that is 80 to the power 1 plus 100 C2 80 square and so on. 100 C100 is 1 times 80 to the power of 100. So 1 times 1 plus 100 into 80,000. So we can write it as 100, let me take common, and here 100 C2 and 80 square we can write it as 8 square into 10 square plus and so on. If we take the third term 100 C3, we will be getting 80 cube, that is 8 cube into 10 cube and so on. 80 power 100 is 8 power 100 into 10 power 100, and it's very clearly we can see that from second term to the last term we can take 100 as a common. 100 can be taken common. It's a multiple of 100, all the numbers. So we can write 1 plus 100 times the any number 80 plus 100 C2, 8 square plus 100 C3, 8 power 3 into 10 plus and so on. Here we can add 8 power 100 into 10 to the power of 98. So whatever this number let us consider to be n. So 1 plus 100 times of some number n, which always ends with this number 100 times n always ends with 2 zeros. 2 zeros for sure. And then for this number so and so number ends with 2 zeros added with 1. So surely we will be getting 1 and 0 are the end numbers, end digits. So we can say 1 plus 1 plus 80 whole power n, that is 81 power 100. 81 power 100 ends with last two digits 0, 1. So therefore last two digits in 3 to the power 400 is equal to 0, 1. Okay. Find the number of terms in the expansion of a plus b plus c whole to the power n. Let us write this as the binomial expansion form. Say a plus of b plus c whole power n So we know that the expansion of x plus a whole power n is nc naught x to the power of n a to the power 0 plus nc1 x power n minus 1 into a to the power 1 plus nc2 x to the power n minus 2 into a to the power 2, and so on. The last term we can take ncn a to the power n. So here let us consider this is the first term and b plus c as the second term. So we can write here nc naught a to the power n into b plus c whole to the power 0 plus nc1 a to the power of n minus 1 into b plus c whole to the power 1 plus nc2 a to the power n minus 2 into b plus c whole to the power 2, and so on. The last term we can write ncn b plus c whole to the power n. So here we can say very clearly the first term a power n into b plus c whole power 0 is 1. So we have only one term nc naught a to the power n. This is only one term here, and here we can see that there are two terms a power n minus 1 into b and a power n minus 1 into c. That is nc1 a to the power n minus 1 into b plus nc1 a to the power n minus 1 into c. These together two terms are there. And similarly in the third term, since the expansion b plus c whole square will have three terms, so we know that x plus a whole to the power n, the expansion of x plus a whole power n will have n plus 1 terms. The number of terms in x plus a whole power n expansion is n plus 1. So here b plus a whole square is 3 terms are there. These 3 terms is multiplied with a power n minus 2. So we have 3 terms together. Similarly and so on, b plus c whole power n will have n plus 1 terms. So the last will have, so here 3 terms. So here 2 terms, and this is 1 term, and so on. The last one will have n plus 1 terms. So we can say that total all terms are, so 1 term, so number of terms, let me write. Therefore number of terms in the expansion of a plus b plus c whole power n is 1, and again here 2 terms, next 3 terms, and so on. We had n plus 1 terms. We have finally n plus 1. So that is, since we know that sum of first n natural numbers, sum of first n natural numbers is n into n plus 1 by 2. So here sum of first n plus 1 natural numbers will be considered n plus 1 into, so we can write n plus 1 into n plus 1 plus 1 upon 2, that is n plus 1 into n plus 2 by 2 terms. Okay. If a and b are the coefficients of x power n in the expansion of 1 plus x whole power 2n and 1 plus x whole power 2n minus 1 respectively, then find the ratio a upon b. So here a is given, coefficient of x power n in the expansion of 1 plus x whole to the power 2n, and we know that in the expansion of in the expansion of 1 plus x whole power n, coefficient of x power r is NCR. Since 1 plus x whole power n is nothing but summation over r is equal to 0 to n NCR into x to the power r. So we can consider the coefficient of x power r is NCR. So by using this concept, we can say a is equal to in 2n c n. 2n c n is the coefficient of x power n, and similarly b is equal to coefficient of x power n in the expansion of 1 plus x whole to the power 2n minus 1. So we can write b is equal to 2n minus 1 c n. So this is a b. Now we need to find a upon b. So consider a upon b, which is equal to 2n cn upon 2n minus 1 cn. Since we know that NCR is equal to n factorial by n minus r factorial into r factorial. So we can write here 2n cn, we can write it as 2n factorial by n factorial into 2n minus n factorial upon again 2n minus 1 factorial upon 2n minus 1 minus n factorial into n factorial. So which can be written 2n factorial upon n factorial into 2n minus n, that is n factorial. The division is nothing but multiplication with a reciprocal. So let us take the denominator terms, 2n minus n, that is n minus 1 factorial into n factorial upon 2n minus 1 factorial. So we can just simplify and we can cancel here n factorial, and also by using the concept n factorial is equal to n into n minus 1 factorial. By using this concept, we can write 2n factorial and 2n minus 1 factorial. So 2n factorial we can write it as 2n into 2n minus factorial. So we can cancel the denominator term, and again here n minus 1 factorial, and the denominator n factorial we can write n into n minus 1 factorial into 2n minus 1 factorial. So we can cancel certain terms, 2n minus 1 factorial and n minus 1 factorial, and n get cancelled, so which you are getting 2. So a upon b is equal to 2 by 1, therefore a upon b is equal to 2 is the answer. Okay. Write the total number of terms in the expansion of x plus a whole to the power 100 plus x minus a whole power 100. We know that the expansion of x plus a whole to the power n is nc naught x to the power n plus nc1 x to the power n minus 1 into a power 1 plus and so on ncn a to the power n. So we can write here x plus a whole to the power 100 is equal to 100 c naught x to the power 100 plus 100 c1 x to the power 100 minus 1 99 into a to the power 1 plus 100 C2 x to the power 100 minus 2, that is 98 into a to the power 2 plus and so on 100 C 100 a to the power 100. Similarly, x minus a whole power 100 will be taken as, so here whenever x minus a whole power n, we will be getting alternate plus minus. So for odd powers we will get negative. So 100 C naught x to the power 100 minus 100 C1 x to the power 99 into a power 1 plus 100 C2 x to the power 98, 100 minus 2, 98 into a to the power 2 and so on up to 100 C 100 a to the power 100. So upon adding both x plus a whole power 100 plus x minus a whole power 100, upon adding, so the odd terms will get cancelled. So we can see that the odd terms get cancelled, 100 C1 and the next 100 C3 and so on 100 C99 also the terms gets cancelled, only even coefficients here will be remaining. So let us consider 100 C naught x power 100 plus 100 C naught x power 100, that is 2 times. We can write 100 C naught x power 100 plus 100 C2 x power 98 into a to the power 2 and so on up to 100 C 100 a to the power 100. So here we can say that there are, and 2 to 100, that is 50 terms are there, and again plus 0, this is 1 term. So total 51 terms we have. So the number of terms in the expansion of x plus a whole to the power 100 plus x minus a whole power 100 is equal to 51. So 51 terms are there, or even just by using the simple formula we can also tell this. In the expansion of x plus a whole power n plus x minus a whole power n, if n is even, then the number of terms is equal to n by 2 plus 1. So here n is equal to 100, therefore the number of terms will be taken. Number of terms is equal to 100 by 2 plus 1, that is 50 plus 1, which is 51. So 51 terms is the answer. Okay, this or. If 1 minus x plus x square whole power n is equal to a naught plus a1x plus a2x square and so on a to n x power 2n, find the value of a naught plus a2 plus a4 and so on a to n. So given 1 minus x plus x square whole power n is equal to a naught plus a1x plus a2x square and so on a to n x to the power 2n. So the expansion is given. So to find a naught plus a2 plus a4 and so on a to n, so let us take, or we can just substitute, make this an equation 1, put x is equal to 1 in the equation 1. So we get 1 minus 1 plus 1 square whole power n is equal to a naught plus a1 into 1 plus a2 into 1 square and so on a to n into 1 to the power 2n. That is 1 minus 1 0, 0 plus 1 square is 1 power n is 1 is equal to a naught plus a1 plus a2 plus and so on a to n. So let us consider this to be equation 2, and then now put x is equal to -1 in equation 1, so that we can write 1 minus of -1 plus -1 whole square whole to the power 2n whole to the power n is equal to a naught plus a1 into -1 plus a2 into -1 whole square and so on a to n into -1 whole to the power 2n. So we can write 1 negative of -1, that is 2, 1 plus 1 whole power n is equal to a naught, this is minus a1 and plus a2 and so on a to n. -1 whole power 2n is, since we know that -1 whole to the power of n is equal to plus 1 if n is even and -1 if n is odd. If n is odd, you will get -1, and if n is even, you will get +1. So -1 whole power 2n is, it's a 2n is an even number. It's 2n is a even number, so you can get +1. So finally we can write 1 plus 1 plus 1 whole power n, that is 3 power n, is equal to a naught minus a1 plus a2 minus a3 and so on up to a to n. So let us consider this an equation 3. Now adding these two equations, equation 2 and equation 3, so we have 1 plus 3n is equal to a naught plus a1 plus a2 and so on a to n plus of a naught minus a1 plus a2 minus a3 and so on a to n. So 1 plus 3 power n is equal to, so a naught and a naught positive terms, so we will get 2 times of a naught, and a1 positive and negative gets cancelled here, and a2 also, a2 and a2 2 times we will get, so we can consider 2 times of a naught plus a2 plus a4 plus and so on a to n. So we can write a naught plus a2 plus a4 plus and so on to a to n is equal to 1 plus 3 power n upon 2. So the answer is 1 plus 3 power n upon 2, or 3 power n plus 1 by 2 is the answer for the question. Okay.